Hello everyone, today let's take a look at Quantipus number 71, another combinatorics question where we have 10 identical $1 bills to be handed out to 4 customers so that each ends up with some total amount. So each customer may receive 0 more bills, so in how many different ways can the customers receive their money? So now what does this mean exactly? Well, imagine I had 4 customers, then I could distribute the money like so. Imagine I gave the first one $5, and then I could give this one $0 maybe, this one $1, and then this one $4, right? So we're trying to count the number of ways that we can distribute money like this such that these 4 numbers add up to 10 because that's how many $1 bills we have. So first thing to notice is that this problem setup right here is essentially the exact same thing as finding the number of solutions to this equation right here where each x represents the number of dollars distributed to the person in the subscript. And this is just under the constraint that all these xi's have to be between 0 and 10, obviously. So now to think about solving this, we're going to use something called the stars and bars method. And how you think about it is basically imagine I have my $10 bills right here, and I want to distribute them to 4 people. So I kind of want to group them into 4 different groups. And how can I do that? I can essentially draw lines, and I can say, for instance, this line represents everything to the left of it will go to person 1. Then maybe I can draw another dividing line here, and then everything in between these 2 lines will go to person 2. And then maybe I can draw another dividing line here, and everything in between here will go to person 3. And then maybe everything past this line will go to person 4. So as you can see, to divide these dollars into 4 groups, I only needed 3 lines. So here's another way I could draw my lines to divide the $10 bills. And in this situation, everything to the left of this line will go to person 1. So person 1 will get 4. Now person 2 will get $6 because we're in between line 1 and line 2. And notice that person 3 will get 0, and also person 4 will get 0 because there's no dollars in between those lines. So now really the key thing to notice is that the solution to this problem is just going to be the number of ways that we can place 3 lines in between these dollars, right? 3 lines because we need to divide into 4 groups. So how do we reframe it into a combinatoric sense? Well, look here, I basically have 13 items, right? $10 bills and 3 lines. So it's essentially like saying I have 13 places to put these items, so how am I going to place my lines? What's the number of ways that I can do so? So I have 13 places, so how many ways can I place 3 identical lines on here? These are 2 examples. Well, it's just going to be 13 choose 3, right? Now you can see that once I choose my 3 lines, I can just fill in the remaining slots with the $10 bills, and this is going to count every single combination of ways to divide this up. So this is going to be our final answer, 13 choose 3. It's going to equal 286. So there are 286 ways to distribute $10 bills to 4 people.